Well, everybody, we're back, and it's time to fire up processing and take a look at how we're going to make the magic happen with code. So we're going to finish off our number to binary converter using LED lights and using a potentiometer to have a little bit of user input as to what number is selected on the screen. And your wired components should look something like this. So we have our LED lights on the left, we have our potentiometer on the right, everything is wired, everything is good to go. And now let's dive into the code. Remember that we need to import two libraries before we start working with an Arduino. The first one is the serial library, and the second one is the Arduino Fermata library. So I'm going to put those two up at the top. I'm going to set up, leave a little space up here for variables. I'm going to set up my sketch like normal. So we have our setup method up top, and then we have our draw method down below. And we are ready to go. So the first thing we need to do is to declare an Arduino variable. And we're going to do that by saying Arduino, and we will call it Arduino. So Arduino, capital, lowercase, and then we are going to initialize that object into being so that processing knows that it's an Arduino that it's going to be interacting with. So we'll say Arduino, the name of our variable, equals new Arduino, the capital version, the class. And we have three parameters we need to put in here. We're going to put this, comma, and then we're going to put Arduino.list. And I am in index 0. That's the COM port that I'm using. Remember, if you forget how to check what number should be in there, refer to episode 2, where we talk about using the console to figure that out. And last but not least, I'm going to put the connection speed, so 57,600. And now we have an Arduino ready to go. We also need to initialize the pin modes and say that those ports are going to be output ports. And normally we would do that by saying Arduino.pinMode is the method, and we put the port. So port 2 is our first one, and then we put what it's going to be. So Arduino.output. They're all going to be output ports. Now we could copy and paste this 8 times because we need to set all of our ports, ports 2 through 9, as output ports, but the better way to do that would be to use a for loop right here. So I'm going to say for int I equals, and then we're going to start at port 2, so I'm going to say int I equals 2, and keep this loop going as long as I is less than 10 because we want it to stop at 9. And every time we loop through, increment the I variable by 1. And now we're going to go in here, and rather than say port 2, we're going to say put that variable I in there. So this will iterate over every port 2 through 9 and set it to an output port. Let's test and make sure that this works. And we're going to do that by going down into the draw method down below. And we're going to use a similar setup. So I'm actually just going to copy this for loop, the initialized for loop right there. And inside of that for loop, I am going to turn all of the lights on just to make sure they all work, just to start off with. So I'm going to say Arduino, and the command that we're going to use to turn a port on is called digital write. So digital write in camel case, and I'll put port I, and we're going to set those ports to high, which means on. And now when I start the sketch, all of those ports, all those lights should light up. And if they don't, there's a problem. But they should all light up for you at this point. Now, when I stop the sketch, the lights are going to stay on, so I am going to change this back to low just real fast, and I'm going to start the sketch again, and now they'll all turn off. So that is how we tested to make sure all of our lights are wired correctly. And I don't need this anymore, so I'm going to erase that out. That was a test, and it's good to test and debug as you go along so that you don't get to the end of the program and realize that somewhere along the line something is wrong, and that's frustrating. So test as you go. Okay, let's test to see if the potentiometer is being able to read our input. So we're going to create a float variable down here, and we'll just call it num input. And we're going to set it equal to Arduino. And now we're not on the digital ports, we're in the analog ports. So we're going to say analog read, because we're reading from that. And we will say analog read, and I put mine in port 0. So I'm going to put 0 right there. And then let's put that down to the console. So print line num input. And apparently I cannot type input. There we go. Now when I run the sketch, let's see what happens. Down here in the console we should see a string of numbers. We do, and as I turn the potentiometer you can see that this number is going down. Now I'm all the way off, and as I turn it to the left the numbers increase, and now I'm up to 1023. So remember there's 1024 combinations if we include 0 as well in there. Alright, our test was successful. Our potentiometer works, so let's delete that out of there. We're going to leave num input because we do need that data. And what we're going to do is we're going to use a map function. So we're going to say num input equals, I'm seriously having a hard time writing input today or typing it. So num input equals, and we're going to use a method called map. So we're going to say map. Now there's 5 parameters that need to come in here, and they're all floating point numbers. The first one is that we're going to pass in whatever that potentiometer is giving us. So we want to change that, and then we put what it's, the values, the range that it's coming from, and then we want to say the range that we want to change it into. So it's, the values are anywhere from 0 to 1023. And we want to change these values to map onto anywhere from 0 to 255. And now let's do a little test down here. Let's do a print line, and now let's write out num input again. And this, instead of going from 0 to 1023, should go from 0 to 255. So let's see if that works. Press start on the sketch. And it does, and you'll notice that my max value is 255 there. It's a floating point number, which means we have decimal values as well. Well, we don't necessarily want decimal values, so what we're going to do right here is we're going to do what's called casting, and we're going to turn this into an integer value. And we do that by putting an extra set of parentheses right there. We're going to write int before it, and now when we start the sketch and run it, we should see just integer values down here from 0 to 255, no decimals. Perfect. All right, now it's time to write a conversion function. I'm going to create a new function down here, and I'm going to say void bin conv. Can anybody guess what that is shorthand for? Yes, that's right, binary converter. So I'm going to pass in that num input, and I need to say that when it comes in here it's going to be passed in as an integer. And I put an open and closed bracket there, and now I am going to call, rather than write print line right here, I'm going to overwrite that. I'm going to say call this function binconv and pass in whatever the potentiometer gave us after we mapped it onto a new set of values from 0 to 255. So take that number and bring it in here, and rather than put num input right here, I'm just going to call it num, and we're going to work with that number right here. So up at the top, the way that I want to approach this is I want to create a string, and we'll call that string bin, or short for binary, and every time we run through this binary converter, I want to set it equal to nothing. I want to empty it out. And now, as we go through our conversion process, every time that there is a 1, we're going to add a 1 in here. And every time there's a 0 when we convert it, we're going to add a 0. And so we're going to build a string out of 1s and 0s into this string variable called bin. We're going to do that inside of this function right here. So I am going to pause the video here, and I'm going to allow you some time, and you should pause your video as well, some time to puzzle this out and see if you can remember what our algorithm was for taking a number and converting it to binary. Hint, hint, you can look back at our representation module or representation unit and see what that algorithm was in case you've forgotten. But by now you're such good computational thinkers that I bet you can figure it out without even having to look back. So take a while, take a little while, take a long while, whatever it takes, but write this function so that it creates this string. Ready, set, go. So either that took you a long time or it took you a short time. It's irrelevant because you persevered, you pushed through, and you were able to figure out an algorithm that would convert a regular number from 0 to 255 into a binary, an 8-bit binary number. So I've wrote a couple test cases here. Up here I'm printing the num input variable that we got from the potentiometer into the console, and down here I'm printing my binary number, and let's just see if they match up. So I'm going to run this, and down here in the console, starting at 0, that's good, and as I turn the potentiometer you can see my number is increasing, as is my binary number. And here at 255 all of those binary digits, those bits, are lit up as 1s, and as I go back down something similar happens. So test cases again are important to make sure that everything is on the up and up. Really quickly, the formula empties out that binary number, so it says bin equals nothing. It's an empty string. And then I'm using 2 while loops to iterate through right here. So I started by declaring this I variable as 0, and I know that I eventually is going to have to, as soon as I gets to 8, then we're done because we want an 8-bit number. So as long as this number that's passed in is greater than 0, as long as it's not 0, then go ahead and here's our formula. We're going to take whatever is already in binary, and it starts as nothing, it's empty, and it's going to take that number that we pass in, and it's going to take the remainder when we divide by 2. And it's going to add that on, that's what the plus sign means. It's going to add that to whatever's in that number already. So in this case, when it starts off, there's nothing. So it's going to take nothing, and on the left side of nothing, it's going to put whatever the remainder is. That's the mod function right there, the % sign as an operator. And then we're going to divide whatever num is by 2. So num equals num divided by 2. And it's going to iterate through there until there is nothing left, until num equals 0. And iterating I++ every time. So we're adding 1 every time. That while loop will not get stuck. And then if the number is smaller than 255, that's going to leave us a couple blank or empty digits. And so as long as I is less than 8, because we want 8-bit number, then go ahead and take whatever's in bin and add a 0 onto the left-hand side of it. So take what's already in there and add a 0 on the left, and again I++. So this will create this 8-character string value that we will know as bin. So there's our formula right there. Okay, now let's create another function. I'm going to call mine light 'em up. And this is going to be actually taking that binary number. So I'm going to pass in bin. And down here I need to create a new function. So I'm going to say void light 'em up. And we're going to be passing in a string, and that string's name is bin. So we'll just call that binary down here. And what we're going to do is we are going to go through each individual character in that string, and we're going to test if it's a 1 or a 0. And if it's a 1, then we're going to light up the LED that corresponds to that port, and if it's a 0, we're not going to do anything. Well, in fact, we'll turn it off because otherwise it's just going to stay on. So we need an if-else statement in there. So go ahead, remember the command to write to a port is digital write. Go ahead and take a moment and see if you can figure out an algorithm that will make this work. Go. All right, so let's take a look at this function, light 'em up. First of all, we're passing in a string, which is our binary number. And we're going to iterate over each character in that string using a for loop. So there's going to be 8 characters, so I'm going to go j equals 0 and keep this loop going as long as j is less than 8. Every time increment j by 1. And I'm going to use 2 methods here to test in my conditional that can be used on strings. The first is called substring. So a substring tests a portion of a string. And I want to look at that first digit, first character in my string. So I'm going to say test between j and j plus 1. And this is going to start off with, when j is equal to 0, it's going to say looking between 0 and 1. And if that equals 1, then go ahead and do a digital write and turn the light on. And I set it to port j plus 2. The reason is because I didn't start wiring in port 0. In fact, there is not a well, there is a digital port 0 and there is a digital port 1, but those are not used in our wiring schematic. So we are going to start at port j plus 2 and turn it on. Otherwise, if it's not a 1, it must be a 0. So go ahead and turn it off. And when we run this program, it should be good to go. The other thing I want to keep in that you may run into this frustration is if you have print lines anywhere up top to test your code by writing it into the console, go ahead and get rid of those right now. And the reason being is because writing to the console is considerably slower than running these functions, and it's going to slow down the program to the point where it will not make those lights light up how they should. So if you have any print lines up here, go ahead and get rid of them before we run it. And when you do run it, this should be the result. Okay, turning. Oh, that's pretty. Look at those lighten up. And as I go down, the binary number decreases. I would call this a success, wouldn't you? Well, I hope your lights were lighting up just like your face in the morning when you wake up and you realize it's your birthday and that you had a good time putting this together. Well done. I applaud you. Keep up the physical computing, keep up the coding. It's been a pleasure working with all of you this year, and I wish you nothing but accolades and successes in the years to come. This is your course coordinator, Eric Dillerman, signing out one final time. Coders, I salute you.